K2-18b. No, it's not a character from Star Wars. It's a planet 2.5 times the size of Earth and 700 trillion miles away, and it could be home to living organisms.
Astronomers have just made a discovery that's rewriting the timeline of cosmic evolution. Two independent teams of researchers have detected oxygen in the most distant known galaxy, JWST Z14-0. The galaxy itself was initially spotted by the James Webb Space Telescope, but it was the combined power of Webb and the Atacama Large Millimeter Submillimeter Array, or ALMA, that confirmed this groundbreaking finding. In this video, we will explore this discovery, examine its profound implications for galaxy evolution, and discuss how it might change our understanding of the potential for life in the early cosmos. The light from this galaxy, JWST Z14-0, began its journey when the universe was in its infancy, less than 300 million years after the Big Bang. Finding oxygen this early is a discovery that challenges our existing frameworks and forces us to reimagine cosmic history. To appreciate why this is such a monumental discovery, we first need to understand the traditional story of cosmic evolution. Our best models tell us that the universe began 13.8 billion years ago in the Big Bang. Initially, the only elements formed in significant quantities were the lightest ones, hydrogen and helium. All other elements, including the oxygen, crucial for life as we know it, are what astronomers call heavy elements. These heavier elements had to be created through nuclear fusion deep inside stars. This material is then dispersed throughout galaxies when massive stars end their lives and explode as supernovae. This process takes time, which is why finding substantial oxygen in such an early galaxy has astronomers rethinking their models. The rule book stated that significant amounts of heavy elements shouldn't appear until much, much later. Finding a galaxy already enriched with oxygen so early compresses that timeline dramatically. The galaxy JWST Z14-0 now holds the record as the most distant confirmed galaxy ever observed, situated in the Fornax constellation. What makes this discovery truly extraordinary is the journey its light has taken to reach us. The photons captured by our telescopes left this galaxy 13.4 billion years ago, meaning we're seeing it not as it is today, but as it existed when the universe was less than 2% of its current age. This galaxy isn't just a record breaker for its distance. It's also surprisingly bright and large, measuring over 1,600 light-years across. While many bright objects in the early universe are powered by supermassive black holes, researchers believe the intense light from JWST Z14-0 is produced by a massive population of young stars. The fact that astronomers found it in a relatively small patch of sky suggests such luminous early galaxies might be far more common than previously predicted. Detecting this ancient oxygen required the combined power of two of our most advanced astronomical instruments. First, the James Webb Space Telescope identified the galaxy with its near-infrared camera and provided an initial estimate of its incredible distance. But it was ALMA that made the crucial detection. ALMA consists of 66 high-precision antennas spread across the Atacama Desert in Chile, working together as a single telescope. This array operates in millimeter and submillimeter wavelengths, which are ideal for detecting the specific emission fingerprint of elements like oxygen in distant galaxies. Two independent teams, one led by Stefano Carniani from Italy, and another by Sandro Schaus from the Netherlands, pointed ALMA at the galaxy. Both teams independently confirmed the presence of a strong, clear signal from oxygen. This detection provided an extraordinarily precise measurement of the galaxy's distance, which is crucial for placing it correctly in the timeline of cosmic evolution. The technical achievement behind this cannot be overstated. Detecting specific elements in a galaxy whose light is so incredibly faint and has been stretched by the expansion of the universe pushes the boundaries of our technological capabilities. The detection of oxygen in JWST Z14-0 has profound implications for our understanding of galaxy evolution. Traditional models posited that the earliest galaxies should be chemically pristine, composed almost entirely of hydrogen and helium. Heavier elements were thought to accumulate gradually over billions of years. However, this new discovery reveals a galaxy that is chemically mature far earlier than expected. Sandro Schaus, lead author of one of the studies, describes this surprising find as finding an adolescent where you would only expect babies. Astronomers discovered a cosmic teenager in a nursery of infants. For oxygen to be present in such quantities, several generations of massive stars must have already lived, died, and enriched their surroundings. This suggests the process of star birth and chemical enrichment were not only fast, but remarkably efficient. This has a ripple effect on other cosmic mysteries, particularly the era of cosmic reionization. After the Big Bang, the universe was filled with a fog of neutral hydrogen. The intense radiation from the first stars and galaxies is thought to have cleared that fog, making the universe transparent. The existence of such a luminous galaxy so early on suggests that these first galaxies were the primary drivers of that process. As Stefano Carniani, who led the other team, emphasizes, the detection opened a new view on the first phases of galaxy evolution. These discoveries are happening right now, with new data changing our understanding of the universe almost every day. If you enjoyed learning about the oxygen detection in the most distant known galaxy, please like this video and subscribe for more cosmic revelations. Perhaps most significantly, this finding reminds us that the universe continues to surprise us. The first galaxies were not primitive. They were dynamic, complex systems already building the elements necessary for planets and eventually for life. This discovery inches us closer to answering one of humanity's most profound questions: how common might life be in our universe? JWST Z14-0 has shown us that the story of our cosmic origins and the emergence of the building blocks of life began far earlier and was more dramatic than we ever imagined. Until next time, keep looking up and wondering about the magnificent universe we're privileged to explore.